You can recall the scene when we learned arithmetic in the first grade of primary school. We first learned the 10 numbers from 0 to 9, and then learned the 4 operations of addition, subtraction, multiplication, and division. In our daily life, we can use this knowledge to count the quantity of goods, plan the time, or calculate accounts. Later, we learned more complex calculation methods. We learned that calculation can also be applied to product manufacturing, architectural design, and earth environmental measurement. However, after entering high school, we began to realize that human computing ability is not so strong. For large number operations, it is difficult to calculate 5-digit multiplication with pen. For graphic calculation, calculate the perimeter and area of simple figures such as circles or triangles at most. As for numbers with more digits or more complex graphics, I'm afraid there will be a mess in my head, and there is no way to start. Fortunately, we can use calculators. There are many kinds of calculators, and here all the machines used for calculation are collectively referred to as calculators. Our most familiar calculator is electronic calculator. Before the invention of electronic calculators, people used abacus to calculate. After the emergence of calculators, the operation speed of multi-digit numbers has been greatly improved. More complex calculations can also be completed by computers. After learning the equations with unknown numbers such as x and y, we can list the calculation formulas without using specific numbers, and then write programs according to these formulas. In this way, complex calculations that are difficult to complete by written calculation can be handed over to the computer for processing. Whether it is to calculate large numbers of thousands of digits or complex three-dimensional graphics, as long as you know the basic equation, you can find the answer with the help of a computer. The computer is a machine that uses electric energy to perform calculations. It was actually put into use around 1960. It has more computing power than human beings and has now been integrated into our daily life. However, even computers that use electricity have limited capabilities. In the past 60 years, the computer has been developing continuously, not only achieving high-speed computing, but also becoming simpler and simpler to use. However, the problems that human beings want to solve are also becoming more complex and cumbersome at the same speed. For complex three-dimensional objects or substances with quantum mechanical behavior, even the most advanced computers cannot easily perform simulation calculations. It is undeniable that sometimes in computing, computers are still beyond their capabilities. The blockchain technology that has attracted much attention recently is based on this fact. Another widely concerned machine learning technology is also committed to reducing the time spent in solving problems. Therefore, it is crucial to break through the limits of today's computers, and people believe that the world will become a better place. So, how can we break through the limits of computers? Quantum computer is undoubtedly one of the answers. What is quantum computer? At present, researchers are actively developing quantum computers as the next generation of high-speed computers. For the numerous problems faced by modern computers, even if quantum computers can only solve a small part of them, it will also bring huge impact to society. First of all, let's briefly introduce what a quantum computer is. The author defines a quantum computer as a computer that actively uses the unique physical state of quantum mechanics to achieve high-speed computing. The quantum in quantum computer is exactly the quantum in quantum mechanics. Quantum mechanics is a course offered at the university stage. As one of the branches of physics, it is a theory developed to explain the motion of tiny matter such as atoms and electrons. Quantum mechanics tells us that unusual mysterious phenomena will occur in tiny substances such as atoms, electrons, and photons, particles of light, and in substances cooled to extremely low temperatures such as superconducting substances, which can be confirmed by experiments. For example, researchers have realized the unique physical states of quantum mechanics such as superposition states and quantum entangled states. So why not actively use these unique physical states to make computers? It is based on this idea that the quantum computer was born. Quantum computers can perform quantum computing far beyond the computing power of traditional computers. With the deepening of research, the potential of quantum computing, which is essentially different from traditional computing, has gradually emerged. The development of quantum computers, that is, to develop a quantum computer that can break through the limits of traditional computers by precisely controlling quantum, has become a major challenge in physics and engineering. The difference between quantum computer and classical computer. First of all, computation can be roughly divided into two categories. One is based on classical computation of classical physics, which is one of the branches of physics, and the other is based on quantum mechanics, which can also be said to be quantum physics here. We have learned the motion of objects, the action of force and the characteristics of electromagnetic field in the physics classes of junior high school and senior high school, which belong to the research scope of classical physics. The research content of quantum mechanics includes the properties of atoms and electrons, which will only be learned in some professional courses in universities. We can think that classical computation and quantum computation correspond to these two kinds of physics respectively. Here, we call the devices that perform quantum computing quantum computers, and the devices that perform classical computing, that is, those common ordinary computers, classical computers. Quantum computing is backward compatible with classical computing, which means that any problem that can be solved by classical computer can be solved by quantum computer. Corresponding to physics, this is equivalent to that any phenomenon that can be treated by classical mechanics, in principle, can be treated by quantum mechanics, that is, classical physics is an approximation of quantum mechanics. In addition, people have found that sometimes quantum computers can quickly solve problems that are difficult to be solved by classical computers. This phenomenon corresponds to the fact that quantum mechanics can even deal with phenomena that classical physics cannot deal with. At present, there is no accepted definition of quantum computer. It should be noted that although the operation of ordinary computers is also inseparable from semiconductor devices, such as transistors and flash memory, that utilize quantum mechanical phenomena, the calculations performed on them are actually corresponding to the classical calculations of classical physics. We need to clarify the difference between physical phenomena for realization and calculations that can be actually performed. Just using phenomena that can be explained by quantum mechanics does not mean that quantum computation can be performed. To perform quantum computation, we need to accurately control the phenomena that can be explained by quantum mechanics and realize the so-called special physical state of quantum mechanics. Types of quantum computers. Quantum computers can be divided into the following three types, as shown in the following figure. 1. Universal quantum computer. Universal quantum computers can perform arbitrary quantum computation. A more detailed explanation is that the universal quantum computer can convert an arbitrary quantum state into another arbitrary quantum state with sufficient accuracy. The so-called arbitrary quantum state refers to the state of any number of quantum bits, also known as qubits. The reason why the accuracy is high enough is that 100% conversion is difficult. We can call this kind of quantum computer universal quantum computer by transforming any quantum state into the desired state. In addition, as the number of qubits increases, the conversion to be performed will become more and more complex, and the impact of noise will also become greater. Therefore, quantum computers must be able to correct errors in the calculation process, with fault tolerance. A quantum computer capable of fault tolerance is called a quantum computer capable of fault tolerance. 2. Non-universal quantum computer. Non-universal quantum computers cannot perform any quantum computation, that is, they can only perform part of quantum computation, but they also show their advantages over classical computers. The quantum computer named NISQ, Noisy Intermediate Scale Quantum, belongs to this category. This kind of quantum computer is currently in the research and development stage, and does not have fault tolerance capability, or weak fault tolerance capability. 3. Non-classical computer. Non-classical computers use, or are intended to use, the unique physical state of quantum mechanics to perform calculations, but have not yet shown a better side than classical computers. The quantum annealing computer currently being developed belongs to this category. Types of quantum computing models. The calculation model refers to the model that describes the calculation execution method. The classification of quantum computers is introduced from the hardware point of view. In addition, there are also types of calculations. Here, quantum computing models are divided into general and special types. Universal. Universal model can describe all quantum computation, and quantum circuit model is a typical universal model. In addition, there are many models that are equivalent in computational quantity, such as measurement-based quantum computation, adiabatic quantum computation and topological quantum computation, which are still in the research stage. The quantum circuit model uses quantum circuits and quantum gates when performing calculations, which replace the circuits and logic gates used in classical computers. This model has been used since the beginning of quantum computer research, and is the most standard model that can describe general quantum computing. Special type. Specialized models can describe specific calculations. There is a calculation model called quantum annealing, which is specially used to calculate the ground state of Ising model. The way to solve the problem is to map the problem to Ising model. Fundamentals of quantum computer. I believe you have got a general impression of quantum computers. Next, let's look at the working mechanism of quantum computers. Operation process of quantum computer. First, let's look at the basic operation process of quantum computer. The basic operations shown in the figure below can be used for both quantum circuit models and quantum annealing. Next, the author will follow these 3 steps to explain how to perform calculations on a quantum computer. 1. Initialize qubits. Quantum bit is the smallest unit of calculation in quantum computer, and is the quantum version of the basic concept of bit in classical computer. Quantum computers usually use quantum bits prepared by physical means to perform calculations. Therefore, quantum bits should be prepared and initialized before calculation. 2. Quantization operation. In order to realize computation, quantum computers must quantize the qubits prepared by physical means. Specifically, the method of operating quantum bits is called quantum gate operation in quantum circuit model and annealing operation in quantum annealing. 3. Read calculation results. Finally, in order to obtain the calculation results, we need to measure the state of the quantum bit, quantum state, and read the information of the calculation results from it. The quantum state is very fragile. In the calculation process, that is, when the quantization operation is executed, any extra measurement will destroy the quantum state, leading to the error of the calculation result. Therefore, we can only measure it carefully when necessary. The general process of research and development is to break through the limits of classical computers, and then move towards the realization of quantum computers. There are still several transitional stages in the R&D process. Up to now, some devices between classical computers and quantum computers have come out, and some devices are still under study. In this section, the author will introduce the various development stages of quantum computers along this R&D roadmap. You can use this as a reference to understand the positioning of each quantum computer. First of all, after the popularity of classical computers, researchers began to develop a device that can make full use of quantum. This kind of equipment can be called non-classical computer, and quantum annealing computer is one of them. This stage can be described as the initial stage of trying to introduce quantum into the calculation process. Next, it is the non-universal quantum computer stage, which proves that the computing power of classical computers can be surpassed. Quantum computers can efficiently perform calculations that are difficult to perform by classical computers, which have advantages over classical computers. This phenomenon is called quantum hegemony, quantum superiority. Whether the quantum device being developed can realize quantum hegemony is the focus at present. At this stage, quantum computers do not have mature fault-tolerant capability, nor can they perform universal quantum computing. Therefore, only by improving the fault tolerance ability can we achieve the ultimate goal of developing a universal quantum computer. It is said that the universal quantum computer will take at least 20 years to develop. However, the research and development work at the current stage of preparation is proceeding steadily, and quantum annealing computers and equipment called NISQ have come out. The future of quantum computer. There are a wide variety of classic computers, from supercomputers such as large computers to desktop computers, notebook computers, smartphones, wearable devices and other small computers, all belong to classic computers. We can choose the most suitable one according to the purpose. So how do we use quantum computers? The present situation of quantum computer. At present, the research and development of quantum computers is in the stage of non-classical computers. Some devices are being tested through the cloud, and several companies are building environments that can test non-classical computers. However, at present, the functions we can use are very limited, and no quantum computer can break through the limits of classical computers to reach a certain practical level. For example, IBM Q is a quantum computer launched by IBM that can be used in the cloud. At present, it can use a quantum circuit model of 5 qubits and a quantum circuit model of 16 qubits to perform calculations. However, such computing power can also be achieved by using ordinary classical computers, such as personal computers. In other words, although the quantum computer with 5 qubits can be classified into the above non-classical computers, it is not very practical. If it is a quantum computer with 50 qubits and a quantum computer with 100 qubits, it is another matter. Therefore, in order to realize quantum computers with higher performance, researchers are stepping up research and development. Due to the huge amount of computation, it is difficult to simulate the computation performed by a quantum computer with about 50 high-precision qubits, even the best supercomputer today. It can be seen that quantum computers can achieve quantum hegemony only when they reach this level. Quantum hegemony means that quantum computers can show their advantages over classical computers. How to use quantum computer? Let's try to look into the future and imagine that the non-universal quantum computer and quantum acceleration have been realized. At that time, quantum computers will solve problems that are difficult to solve by classical computers and become part of the system. Please note that the quantum computer will be integrated into the system. At this stage, people generally believe that quantum computers belong to special machines. In other words, the quantum computer is only a machine for quickly solving certain specific problems. Theoretically, quantum circuit model can describe general quantum computation. Any computation that can be completed by classical computer can also be completed by quantum computer, but in fact, considering the cost, people only temporarily use quantum computers to assist classical computers. Therefore, we will not consider the situation that every family has quantum computers or that smartphones are integrated with quantum computers. The above figure describes a quantum computer composed of superconducting circuits. This kind of quantum computer requires not only a large cooling device called dilution refrigerator, but also a large number of control devices. We can temporarily use such quantum computers through cloud services. Looking forward to the future computing environment. In my opinion, the structure of the computer in 10 years' time will be as shown in the figure above. First of all, we will connect personal computers, smartphones and wearables around us through wireless LAN.